Hi, welcome to our math. Today I'm doing a series of videos on an exam review. This is an exam I did in my class several years ago. And basically I'm gonna create an answer key showing how each problem is done in this exam. This exam covers lines, matrices, and linear programming. I'm gonna break this up into probably 5 videos. I did it all in one video and my computer will not create it. I've spent hours trying to create one video. It ended up being about an hour long. So I'm gonna create 5 videos, one for each page of this exam. This first page has, this is a line, cost, revenue, profit, and a few others, and we'll see how it goes. So a new business owner wants to sell food from a food truck. The monthly expenses for running the food truck are $3,600 per month, and cost for food is $3, and they're selling for $12. So first of all, it says find the cost function. Regardless of anything else, if you're asked to find a function, you need an equal sign. Even if the problem has a C of X in it, at least when I create problems, you always need to create a full function. So C of X equals all of the costs. The cost is how much it is per meal, and the expenses, so plus 3,600. The revenue is, so this is the money out, this is the money in. The money in is what people pay. Don't do any math in creating these. These are literally just what you're paying, what you're getting in. The next 2 questions discuss the math of the problem. Profit is the difference between these. And we want the revenue to win in the battle between costs in and out. You want to make more money than you spend. So our profit is hopefully more revenue, so we do revenue minus costs. When I calculate this, 12x minus all of, so I put this in parentheses, 3x plus 3,600, I'm not done. You're not done until you just have a simple linear, so I'm going to distribute and combine. So I'm going to have 12x minus 3x minus 3,600, and then p of x equals 9x minus 3,600. As for the break-even point, I could set the profit equal to 0. That's fine. That will work. The thing is, if you're not asked to find the profit, you would have to then find the profit first. Or if you did something wrong with your math, like you didn't distribute the negative or anything else, you'd be finding the wrong break-even. So for break-even, what I usually do is I set the revenue equal to the cost, because that's what break-even is. When you start a business, your profit is negative, your costs are more than your revenue, you start off spending a lot of money. And then what the hope is people will buy your product until the revenue catches up with the cost, and then you start making money. So break-even is that point when the money out and the money in equal out, your profit is 0, and then after that you start making money. So when is 12x equal to 3x plus 3,600? We subtract 3x from both sides. We have 9x equal to 3,600. If we divide by 9, we get that x is equal to 400. Here I'm going to label, and what we're selling is meals. So 400 meals. All right, the next question in our linears, matrices, and all of that fun jazz is, of course, a Gauss-Jordan elimination type problem. So it says, solve the system of equation by reducing the augmented matrix. So first I need to create a matrix. A matrix is pulling the numbers out, 5, 4, 15, 3, 2, 31. Augmented means I'm just going to put a line in there, and that line represents the equal sign. It's not actually part of the matrix. It just is a visual help to help us know that there's an equal sign in this matrix. All right, solving with an augmented, essentially what I'm going to do is I'm going to cover up everything but that first column, and I'm going to do something called pivoting. And pivoting means that I'm going to circle this 5. A lot of videos will tell you to divide that row by 5 and have 4/5 and 3. I'm not going to do that. We have enough sticky points in this, and that we are we have matrices and we're doing row operations and we're doing everything else, I don't think we need to bring fractions in as well. So we can divide in the very last step and that's fine. So I don't do fractions within my matrices. So what I want to do is reducing our augmented matrix is all about getting zeros. It's not about the ones, it's about the zeros. So I want to use that 5 to zero out the 3. If I want to zero out the 3, what I need to do is I need to keep row 1 as is. Sometimes I affect that first row, but right now I'm not going to. I don't need to. What I really need to do is I need to take 3 times row 1 and subtract 5 times row 2. If I take 3 times 5 and subtract 5 times 3, 15 minus 15 will give me that 0 that I want. So that is what I'm going to do. Those are the mappings I am going to follow. So 3 times row 1 is going to give me 15, 12, and 45. Minus 5 times row 2 is going to give me negative 15, negative 10. This should be a negative 4, by the way, and that should be a negative 12. Okay, and 100, negative 5. So negative 155. And when I add down, I'm going to get 0, negative 22, and negative 110. And what I'm going to do next is I'm going to divide through by this negative 22 so that this becomes a 0, this becomes a 1, and this becomes a 5. And it saves me a step of writing another matrix. And so I'm going to divide. I'm only doing that because I knew everything in this row was divisible by that 22. If it wasn't, I probably wouldn't have done that yet. We have calculators. We can have big numbers. It's fine. But because everything was divisible, it's going to make my next step simpler. So I still have 5, negative 4, and 15. But now I have 0, 1, 5. I'm going to make this an augmented matrix by putting the line in to represent my equal sign. I'm going to cover up this column. I'm going to cover up this column. And now I'm going to, so I first pivoted on row 1, column 1. I'm now going to pivot on row 2, column 2. And I'm going to use that 1 to zero out the negative 4 above it. I'm going to leave row 2 as is. I can because I've already gotten it down to a 1. I might do more than just leave it as row 2 if it wasn't a 1, but we'll get to that in another example. I need to use that 1 to zero out the 4 because again, the focus is the zeros. I want zeros. So to get to that to be a 0, I'm going to do row 1 plus 4 times row 2. I subtracted here because the signs were the same. I'm going to add here because the signs are opposite. So to do this calculation, I start with row 1, which is 5, negative 4, 15. And then I add 4 times row 2, 0, 4, 20. And I end up with 5, 0, 35. Just like before, I'm going to, because 5 goes into 35, I'm going to divide this by 5, and I'm going to get 107. This went into row 2. This is going to go into row 1. I'm going to write my next matrix up here. Row 1 is 107. Row 2 is 015. This means my answer is 7, 5. It's really easy to test. It's really smart to test. People who like math usually like math because you can test. So is 5 times 7 minus 4 times 5 really equal to 15? So 35 minus 20, yeah. Is 3 times 7 plus 2 times 5 really equal to 31? 21 plus 10, yes. So this is my answer. We write it as an ordered pair. We don't leave it in the matrix form. All right, the last question on this page is, let A be a 3 by 3 matrix, 3 by 3. Let B be this 3 by 2 matrix, and let C be this 2 by 2 matrix. If the following operation is possible, give the size of the resulting matrix. If not, state why. Be specific. Do not perform the operations. There's not enough room for the most case to perform them anyway. All right, B times A. So B is that 3 by 2. A is a 3 by 3. To multiply matrices, the middle numbers have to be the same. In this case, they are not the same, so this is not possible. Not possible. Why? Dimensions are not the same. Okay, A plus B. A is a 3 by 3, and we're trying to add a 3 by 2. Again, this is not possible. And not the same being right there. Here it's again, can't add matrices of different dimensions. So none of these could be added or subtracted. All right. A times B. Well, B times A couldn't be multiplied, but the thing about matrices, they're not commutative. It's not A times B, B times A. It doesn't work like normal scalar multiplication. So A is a 3 by 3, B is a 3 by 2. Here we go. Their 3's are the same, so that checks out. The answer is going to be a 3 by 2. So if the middle numbers are the same, the answer is the outside numbers. So if we go down here to finish our multiplication, B is a 3 by 2, C is a 2 by 2. Again, here we go. These are the same, so it checks out. And the answer is once again a 3 by 2. All right, now let's go to these inverses. A is a 3 by 3, so this checks out, and the resulting matrix is a 3 by 3. B is a 3 by 2. This is not possible. Only square matrices can have inverses. And this one might not. This one could end up without an inverse if we started to solve it, but this one just cannot have one because it's not a square matrix. All right. I hope you've enjoyed this video. Please subscribe to my YouTube channel and continue watching for the next part of the exam review. Thanks.